The lens maker's formula is 1 by focal length is equal to refractive index of the medium minus 1 into 1 by radius of curvature of first medium by radius of curvature of the second medium. This is in general. For convex lens, this is the convex lens. This is the first surface and this is radius of curvature. This is second surface. This is second surface. This is the C2. This is the radius of curvature. So this is optic center. The distance, this is from here to here, distance of first one, that is R1, which is nothing but plus R1, because we are measuring the distance from optical center along the ray direction. And R2 is equal to from here to here. This is R2. From here to here, it is along the against the ray direction. So R2 is equal to minus R2. So the equation how it will change for convex lens. For convex lens, the equation becomes 1 by f when it is kept in the air. The lens is kept in the air because refractive index of glass is equal to refractive index of the medium. Refractive index of air is equal to 1, which is equal to refractive index of second medium is equal to refractive index of first medium. That's why mu2 we replaced by mu1 divided by mu1 is equal to 1. It's equal to mu minus 1 into 1 by R1 is plus R1 minus 1 by minus R2, because R2 is equal to minus. Means R2 is equal to minus. So this becomes mu minus 1 into 1 by R1 plus 1 by R2. If it is EQ concave lens, EQ convex lens, for EQ, this is for EQ convex lens. This is for biconvex lens. This is for biconvex lens. For EQ convex lens, radius of curvature first is equal to radius of curvature second is equal to R. Therefore, 1 by F will become 1 by mu minus 1 plus into 1 by R1 plus 1 by R plus 1 by R, which is nothing but mu minus 1 into 1 by R. 1 by R2 is equal to into 2 by R. Or 2 by R, or focal length is equal to focal length inverse of this one. 1 by R plus 1 by R is equal to 1 by R into 1 plus 1 is equal to 2 by R. So focal length inverse this one, R by 2 into mu minus 1. Okay, this is for convex lens. For concave lens, this is the concave lens. This is the first surface. This is R1. This is R2. This is R1 and this is R2. So this is ray direction. Therefore, R1 from the optic center we come here. It means this is R1 is equal to negative, R2 is equal to from here to here. This is surface 1, this is surface 2. So R1 is negative, R2 is positive. So lens formula is 1 by F is equal to mu minus 1. This is for concave. Biconcave lens, mu minus 1 into 1 by R1. R1 is 1 by minus R1 minus 1 by plus R2 is equal to mu minus 1 into plus into minus. This is equal to minus 1 by minus R1 is equal to minus 1 by R1 minus 1 by R2. If it is equiconcave lens, if it is, this is for biconcave lens, biconcave lens. For equiconcave lens, R1 is equal to R2. Therefore, equiconcave lens 1 by f is equal to mu minus 1 into 1 by minus, replace R1 by R1 and R2 by R. 1 by minus R minus 1 by minus 1 by minus 1 by R minus 1 by R. It's equal to mu minus 1 into minus 2 by R, and the focal length is equal to minus R by 2 into mu minus 1. See, the focal length for the concave lens is negative. The focal length for the concave is positive. This is focal length is positive. For this negative. Let us take for biconvex lens. Let's say plano convex lens. One side is plane, other side is convex. This is R1, first one, R1. So this for the first surface R1. So from the optical center we are coming, this is R1, this is negative, and this is R2 is equal to infinity. For plane surface it is equal to infinity. Same way we can put the simply in this equation, put the sign of R1 and R2 for different classes, different lenses, then you will get the focal length formula by using this. Okay, now how to get for convex lens, the focal length is positive, and convex lens it is focal length is negative. How to remember this one? See, always see the ray striking here. This is a shortcut method. Ray striking here, and at the first surface, what is the radius of curvature of the first surface R1? So radius of curvature is here. It means the distance is measured from here. It means the focal length also will be here only. This is center of curvature, the radius of curvature. It means this is the focal length. Focal length is positive because we are measuring from optical center to focal length. That is why look into the first surface. What is its focus? Its focus will be lying here, so it is positive. For concave lens, this is concave lens. This is the first surface, ray striking here. For the first surface, the radius of curvature will be here, and the focal will be also here, on this side. So it is measured from this direction. That is why the focal length is negative. This is the shortcut way to remember. There are other ways to remember also. This is the easiest way. Cauchy's relation, which relates refractive index of medium and wavelength of the light. That is CAUCHO. Cauchy's relation is given by refractive index of the medium is equal to A plus B divided by a lambda square, and it goes. Where A and B are constant, A and B are constants. Constants, it means we can say this is constant, this is constant. So refractive index of the medium is proportional to 1 by lambda square. Refractive index, where mu m is equal to a refractive index of medium. medium, and lambda is equal to wavelength of light. Wavelength of light. And we know by lens maker's formula 1 by focal length. So f is equal to focal length. So focal length is equal to refractive index of the denser medium by refractive index of rarer medium minus 1 into 1 by radius of curvature of first surface by radius of curvature of second surface. So is equal to mu, if it is the second medium is air, suppose this is the lens, this is air, this is air, then this is glass, and this is a denser medium, this is a rarer medium, this is rarer medium. The refractive index of air is equal to 1 and the refractive index of glass is equal to refractive index of medium. So we can write refractive index of medium 2 with respect of medium 1 is equal to mu of medium by mu of air minus 1 into 1 by R1 minus 1 by R2. So this is refractive index of medium, we can simply read as this is equal to 1, refractive index of air is equal to 1. This is refractive index of medium, we will simply write mu minus 1. Yes, refractive index of medium, we are writing it as, or simply we write refractive index of medium. V minus 1 into 1 by R1 minus 1 by R2. It means focal length. It means we can say the focal length, since the radius of first surface and radius of second surface both are constant for a given lens and one is a constant, it means 1 by focal length is proportional to 1 by focal length is proportional to refractive index of the medium. If it is refraction also, from here refractive index of the medium is proportional to 1 by wavelength square, or we can say mu is proportional to 1 by lambda square, which is proportional to 1 by f. It means this and these are proportional, or we can say focal length of the lens is directly proportional to square of the wavelength. This is what Cauchy's relation gives the relation between the focal length and wavelength.